We like to believe we understand our place in the cosmos. We look up at the night sky and feel a sense of familiarity, as if the universe is something we've already mapped, something we've mostly figured out. But every so often, a new window opens, and suddenly that confidence collapses. Because what we're seeing now isn't just more stars, it's not just clearer pictures, it's a revelation that the universe has been holding back its true scale from us, waiting until we were finally capable of seeing it. When light travels across the universe, it doesn't hurry. It takes its time. And that means every image we capture from deep space is a message from the past. Some of those messages began their journey before our planet existed, before our sun ignited, before Earth had even learned how to be a world. We are not observing distance. We are observing history. And what that history is telling us is unsettling. Galaxies appear earlier than they should. Structures emerge faster than our equations predicted. Regions we once believed to be empty are now revealed as overflowing with cosmic activity. The universe didn't gently ease into existence. It arrived already busy, already complex, already ambitious. This forces a difficult realization. Our mental model of the cosmos was built on incomplete vision. Imagine trying to understand the ocean while only seeing its surface. Now imagine finally being able to look into its depths and discovering entire ecosystems you never knew existed. That's what's happening here. Darkness, it turns out, was never empty. It was simply distant. And distance has a way of humbling assumptions. The more powerful our instruments become, the smaller we feel. Not insignificant, just properly scaled. We are reminded that human intuition evolved to survive on a savanna, not to comprehend trillions of galaxies stretched across unfathomable expanses of space-time. And yet we persist. We ask questions. We build tools. We listen to ancient light. What's most profound is not that our theories need revision. That's expected. What's profound is that the universe continues to cooperate with our curiosity. It allows itself to be studied. It leaves clues. It invites us to participate in its story. Every discovery answers one question and raises 10 more. That is not a failure of science. That is its promise, because the universe is under no obligation to make sense to us. And the fact that it ever does is the real miracle. When we talk about the universe being bigger, our minds instinctively imagine more distance, more d by the journey itself, meaning the universe never presents itself directly, only through clues shaped by physics along the way. Every improvement in our ability to observe does not simplify the picture. It complicates it further, revealing layers of reality hidden beneath previous assumptions. Instead of a cosmos that becomes clearer with proximity, we find one that grows more alien the closer we look, exposing how limited our everyday understanding truly is. When people hear that astronomers are looking back in time, it can sound like poetic language, a metaphor meant to make distant objects feel more dramatic. In reality, it is a precise physical description of what is happening every time we observe the cosmos. Light does not arrive instantly. It travels at a finite speed and over vast cosmic distances. That speed turns space into a time machine. When we observe a star 1,000 light years away, we are not seeing it as it is now, but as it was 1,000 years ago, long before modern history ever began. As distances stretch into millions and billions of light years, the effect becomes profound. Entire galaxies appear to us as they existed when the universe was young, when stars were just beginning to form, and cosmic structures were still assembling. Some of the light reaching our instruments today began its journey before Earth formed, before the sun ignited, before the Milky Way settled into its present shape. Observation becomes archaeology on a cosmic scale, where photons act as fossils, carrying information from eras that no longer exist in the same form. This also means the universe is never observed all at once in a single moment. Different regions appear frozen at different ages, layered across the sky like a patchwork of time. Nearby objects represent the recent past, while distant ones reveal ancient chapters of cosmic history. Even the act of observing changes how we think about now, because there is no universal present shared across the universe. What we call the present is local, confined to our position in space. Every image of the deep cosmos reminds us that time is not just something that passes on clocks, but something embedded into the structure of space itself, inseparable from distance and motion. For a long time, our understanding of the early universe followed a careful, almost modest narrative. After the Big Bang, matter was expected to cool, slowly clump together, and gradually form stars and galaxies over vast stretches of time. Complexity was supposed to be delayed, arriving only after the universe had enough time to settle down. Recent observations disrupt that timeline in an unexpected way. Galaxies appear surprisingly mature at epochs when the universe was still in its infancy, showing organized structures, heavy elements, and active star formation far earlier than existing models anticipated. This rapid emergence of complexity suggests that the processes driving cosmic evolution were more efficient than previously assumed. Gravity may have acted faster, gas may have cooled more quickly, and star formation may have ignited at a pace that challenges our simulations. Instead of a slow buildup from simplicity to order, the universe seems to have rushed toward structure, assembling massive systems almost as soon as the conditions allowed. This forces scientists to re-examine the assumptions built into their equations, not because those equations failed, but because the universe revealed behaviors they did not fully account for. What makes this especially striking is that these early galaxies are not faint, fragile objects barely holding themselves together. Many are bright, dense, and chemically rich, implying multiple generations of stars already lived and died within them. That means the cycle of birth, fusion, and destruction began extraordinarily early, compressing cosmic history into a much shorter window than expected. The universe did not wait patiently to become interesting. It became active, complex, and productive almost immediately, suggesting that the seeds of structure were planted deeply and efficiently, reshaping our understanding of how quickly order can arise from cosmic beginnings. For much of human history, darkness in the cosmos was treated as absence, a vast emptiness separating the few points of light we could see. Black regions of space were assumed to be true. Where we stand, cosmology does not shrink humanity, it places it correctly. It strips away comforting exaggerations and replaces them with awe grounded in reality. The universe does not revolve around us, and it does not need to. Our value lies not in size or dominance, but in awareness itself, in the rare ability to look outward and grasp truths that extend far beyond the boundaries of our own experience. There is a common expectation that knowledge brings closure, that each new discovery will neatly resolve the mysteries that came before it. In everyday life, answers tend to shrink uncertainty, offering a sense of completion. In science, the opposite often happens. Every answer reveals the outline of deeper questions, expanding the landscape of the unknown rather than reducing it. This is not a flaw in the process, but a defining feature of how understanding progresses. When new observations confirm or challenge existing theories, they rarely settle debates permanently. Instead, they expose the limits of current models and point toward gaps that were previously invisible. A measurement that seems precise enough suddenly raises questions about what lies beyond its range. A theory that explains one phenomenon reveals inconsistencies when applied to another. Progress does not arrive as a final statement, but as an invitation to refine, rethink, and explore further. This expansion of mystery is especially evident in the study of the universe. As instruments grow more sensitive, they uncover complexity where simplicity was assumed and order where chaos was expected. The universe responds to our curiosity not with final answers, but with richer detail. Each layer of understanding opens into another, larger layer, suggesting that reality is structured more like an unfolding story than a solved puzzle. What sustains scientific exploration is not the promise of certainty, but the acceptance of incompleteness. Curiosity thrives in the space between what is known and what remains unexplained. The unanswered questions are not signs of failure, they are markers of progress, evidence that we have pushed far enough to encounter the edge of our understanding. In this way, mystery is not an obstacle to knowledge but its engine, ensuring that the pursuit of understanding remains alive, dynamic, and endlessly open to discovery. As we pull all of this together, one truth becomes impossible to ignore. The universe did not simply grow larger in our understanding. It grew deeper, stranger, and more humbling. What once felt familiar now feels vast beyond comprehension. We have learned that distance is time, that darkness is full, that complexity arrived early, and that our place in all of this is far smaller than our instincts would like to admit. And yet, within that smallness lies something remarkable. The universe has produced minds capable of questioning it, of building tools to listen to ancient light, and of adjusting beliefs when reality demands it. What truly changed is not the universe itself, but our relationship with it. Each discovery strips away another layer of assumption and replaces it with awe grounded in evidence. We are reminded that knowledge is not a destination but a journey that keeps expanding the horizon. The more we understand, the more honest we become about how much remains unknown. That humility is not discouraging, it is empowering. It invites us to keep looking, to keep wondering, and to accept that mystery is not the enemy of understanding, but its partner. To everyone listening, good luck on your own journey of curiosity. Keep asking questions that feel too big, keep challenging ideas that feel too comfortable, and never lose the sense of wonder that drives discovery forward. Thank you for your time, your attention, and your willingness to look beyond the familiar and into the vastness that surrounds us.